This is dealing with what we call the cosine law. And, you know, I guess what I could tell you is you use the sine law whenever you know two sides, let me start again. What I can tell you is you use the sine law if you have an angle-side pair. So that means you're going to use the cosine law if you don't. And there are two situations that can arise here, and one of them will be a situation in which you find an unknown side of a triangle using the cosine law. But in the situation where you find the unknown side of the triangle using the cosine law, you do not start by knowing a pair. The other situation is sometimes we have to use the cosine law to find an angle. But again, when you do that, you do not know a pair. So in any triangle ABC with sides A, B, and C as shown, the cosine law appears in two ways. One is this: a squared equals b squared plus c squared. It looks suspiciously like the Pythagorean theorem. The missing side squared equals the other side squared and added together, but then there's this minus 2bc times the cosine of angle A. And I want you to note that some students, and I myself have been guilty of doing this, sometimes you just forget about that too. I don't know why. It's there. I know it's there. But after working with the cosine law for 35 years in classrooms, sometimes I will forget about the 2. Which means you're going to forget about it sometimes maybe. And for whatever reason, I don't often do this, if ever, but for whatever reason, people think that's plus. They get going on their calculator and they go plus. It's minus. One of the things I want you to note is that in the cosine law, there is a pair. Okay? It happens to be in this formula. It happens to be in this formula the A pair. And I will tell you right now that this pair is always the pair that has half you're trying to find. So if you ever use this form of the cosine law, you are trying to find side A, and you must know the other two sides, and this is important, the other two sides and the angle between them. Like when you look at B and C, it doesn't really matter which is which, and you'll see why in a little bit. They are the two sides that you do know. You know them. You're going to have numbers there. And when you look at angle A is the angle between those sides. So whenever you have two sides and the angle between them, you use the cosine law to find the other side. However, if you know all three sides, so you know all three sides, this is the information that you know. I'm not distinguishing between which one is which. You just know all three sides. You can use that to find an angle. But do you see, looking at the top formula for the cosine law, that B and C in the equation are treated differently than A? Like B and C are on the other side. The squares are added together, and then B and C are multiplied together. A is a lone wolf, so to speak. In the bottom formula, A is a lone wolf. Little a is treated differently than B and C. So if you know all three sides, you can use this form, this bottom formula, to find angle A. But whatever you call it, this angle you're finding will be the angle that pairs up with the oddball side on the other side of the equation. And I'm going through this explanation because the triangles are not always ABC. In fact, I wouldn't even use that. I wouldn't even, you'll get so used to these forms of the cosine law that you don't even worry about looking at them. You will know the pattern. So let's get going here. Explain why you cannot use the sine law to find the length of side BC, also known, if we want to add some things here, as side A. Why can we not use the sine law to find side A, because we don't know an angle side pair. Right? You don't know, well, you know little c, but you don't know big C. You know little b, but you don't know big B. You know big A, but you don't know little a. You need a pair to use the sine law, so we're going to use the cosine law. And the cosine law says this. Now, keep in mind, I've designed this first example, which I pulled from the textbook. It's designed in such a way so that what we're going to do matches this formula that will be on your formula sheet, okay? But it doesn't have to. So listen to how I describe what we're going to do with the cosine law. When you know two sides and the angle between them. The missing side squared is the other side squared plus the other side squared minus 2 times the other side times the other side times the cosine of the angle that's between those two sides. Those two other sides can be labeled as whatever. It doesn't matter. And the side you're finding can be labeled as whatever. It's almost like a pattern, like a rhythm to a song or a tune. You square the side you know, you add the square of the side you know, you subtract 2 times the product of those sides times the cosine of the angle that's between the two sides. And do not overthink this. You can put this into your calculator in one shot. I write brackets up here because I don't write times with an X because it looks like an X. You don't need any brackets. And by the way, this does not mean that times cos of 47. It's not what it means. It means take this and subtract this whole thing. It's not going to matter because we're not going to enter it in pieces anyway. But sometimes people are confused about the meaning of this. So we just go 10.4 squared plus 21.9 squared minus 2 times 10.4 times 21.9 times cosine of 47. I mean, I'm forced to use a set of brackets around that angle. And I hope it's clear before I hit equals that the order doesn't matter anywhere here. Like I could have 21.9 squared plus 10.4 squared and then the rest the same. It doesn't matter. Because the order in which you add or multiply makes no difference. Double check it all, I hit enter. That is not the value of a, that's the value of a squared. So you take the square root. That's it. When we take the square root here, there's no need to write plus or minus for you Physics 20 people because a is the length of the side of a triangle. Lengths are positive. So 16.6, approximately. What are we doing in centimeters? Any questions with that first one? It's really pretty straightforward. It's calculator work. Well, now we have to put this together. Well, we don't have to. How many of you can see? I was going to say we have to put this together to get a diagram. But how many of you can see that this is telling you two sides and the angle between it? If we wanted to find side C, just don't write this down necessarily. I will draw a diagram. But if we wanted to find side C, then you would write this. Wouldn't you? That's not the formula that's on your formula sheet. The formula on your formula sheet says a squared equals. Well, what if we want to find c? Well, then you'd write c squared equals. However, let's draw this because some people will benefit from it. And as well, we have to find the other angles, so we might as well get a good picture of it. I would tend to draw this as if I were setting it up with the ambiguous case. I would draw this to be 11. I know the angle is 20 degrees. That's a pretty shallow angle. And this is 5. That looks pretty good. Let's label things. If this is B, this is angle B. If this is A, this is angle A. And that leaves little c, which we don't know, and big C. Okay, one thing before we get going here. There's no ambiguity about the cosine law ever. The cosine law will always give you the right answer. It's why I sometimes just rely on it almost exclusively. Here we're going to write c squared equals 11 squared plus 5 squared minus 2 times 11 times 5 cosine 20 degrees. Everybody calculate b for me. So we run it through the calculator, take the square root. Does anybody else get 6.5? Okay, I took some shortcuts. I multiplied 2 by 11 by 5 in my head. So 6.52. Now, are we okay with that? Okay. I have not taught you how to use the cosine law to find an angle, and that means you have to use the sine law. But looking at that diagram, and this is why I think drawing it is important, do you see that angle A looks suspiciously more than 90 degrees? What that means is there's an ambiguity here, because if I use the sine law to find angle A and I go inverse sine, it's not going to give me an angle more than 90. So I would find the angle using the sine law that I know to be less than 90. Then I don't have to worry about turning this around and talking about the height and a dangling side and all that. Okay. So what am I going to write here? I'm going to write sine B over 5 equals, I guess, sine 20 over my answer of 6.52. And then we'll be done. Well, then we have to find that third angle, but that's easy. So what do I need to do? I need to go 5 sine 20 and divide by my answer. Oh. I need to take 5 sine 20 and divide by my answer and take the inverse sine of the answer and get 15 degrees. So angle B is 15 degrees. I hope you're okay with me not even writing anything to find that top angle. The three angles have to add up to give 180, don't they? That's the rule. 180 minus 35 is 125. Is that right? No. 145? And we're done. Any questions with that second example? All right. So I'm going to cut through make some shortcuts here because I want to get through this lesson and I want to give you some time to work on stuff. What this is saying is we have a triangle and you're given the 3 lengths. There's a 19-meter length, there's a 12.2 meter length, and there's a 14-meter length. And the simple fact of the matter is if I gave you 3 pieces of wood, balsa wood, of those lengths in centimeters and said make a triangle, you're all going to make the same triangle. There's only one way to put them together. You connect the ends. So we take the longest piece and we connect the next longest piece, which is 14, which is a little bit less than 19, and then we connect the 12.2, and I don't really particularly care how accurate this is as long as it looks reasonable. This is 19, 14, and 12.2. Determine that angle. Well, you cannot use the sine law, so you have to use the cosine law. But we're using the cosine law to find an angle, so we're looking at this. Cos A equals b squared plus c squared minus a squared over 2bc. See, I didn't tell you this, but I will now. I forgot to. This is just the other formula rearranged. It's not a different formula. It's somebody has rearranged the formula for us. So we put in the numbers. Now, there's no ABC here, but all that is important is the angle you were trying to find is across from the oddball side, which means this side that is treated differently in the formula must be the 14 that's across from the angle we're trying to find. And all you're going to do is write cosine of that angle is 19 squared plus 12. Is that 12.2? Thank you. 12.2 squared minus the 14 squared over 2 times 19 times 12.2. Now, can you enter this all in your calculator at once? Yes, but you need a single set of brackets around the entire denominator and a single set around the entire numerator, unless you want to do it in pieces. Which I do. This is how I do it. I go 19 squared plus 12.2 squared minus 14 squared. I hit equals. And those of you that have me for Physics 20 will be more familiar with this idea. I don't multiply that out. I just say I have to divide by 2. I have to divide by 19. I have to divide by 12.2. That's the equivalent of dividing by the product of those things. And now I go inverse cos, and I have my answer. So about 47 degrees. Are we okay with that one? Now, I want to go back and look at this. And I want to go all the way back to where we were here. And I'm going to ignore the angles. Do you agree that this angle was in fact more than 90? Which means the sine law fails us when we find that angle with the sine law. It would not give us the right answer. We'd have to go, oh, that can't be right, and take 180 minus whatever it gave us. The cosine law doesn't fail us. The cosine law would be, I'm trying to find this angle, it would be 5 squared plus this squared minus this squared on the top. 5 squared is 25 plus, find that number. There it is. That squared minus 11 squared, and then I have to do, now it's negative. That's interesting. It's negative. We haven't really talked about this. And I need to divide that by 2, and I need to divide it by 5, and I need to divide it by that 6.52. And I get a negative for a cosine. Wait, cosine is negative in quadrant 2. The rotation angle is more than 90 degrees. So when I go inverse cos, I get it. I get that. We had 145 up there, right? And if you carried all your decimals, that's what you'd get. I'm going to change question 4 to 2 questions. Find x and find x. Okay? And I'm going to do this on my calculator. Maybe I'll write something down for B. And I don't want to try to pressure you into skipping all kinds of work. But I know some of us can do this. I hope all of us can do this. I'm going to take 14 squared plus 12 squared minus 2 times 14 times 12 cos 62. This is an example of finding the missing side when you know the two sides and the angle between them. Are you with me on this? Okay. You can write this down if you like. I'll just drop it here if you feel the need to write down what we've done. But sometimes, particularly when we're practicing, I think it's okay to cut corners and just say to yourself, do I know how to get the answer? But you have to try it to see if you can get the answer. You can't just go, well, I know how this works and not do anything. So we hit equals. Does that mean x is 182? No, we have to take the square root. Well, 13.5, which looks reasonable on that diagram. We okay with 4a? Talk to me here. Are you guys okay? See, I think this form of the cosine law where you're finding a side is pretty easy. This one is maybe a little more complicated. You understand what I'm saying when I say that's the oddball number? It's the one in the formula that's minus on the top. When we have p squared minus plus q squared minus r squared over 2pq equals cosine of r, I'm saying that that is the one that goes there. Because it's the one opposite the angle. That's the way it works. That's the pattern. So I have to take give myself a bit more room. I can't do that. I have to take 11 squared plus 30 squared and subtract 25 squared and divide that by 2 times 30 times 11, which is 660, I think, to get, rats. I have to divide that by 660, which I think is, that's right, 2 times 30 times 11. And I get 0.6. Oh, okay, r is the inverse cosine of that, 53. This angle down here is clearly greater than 90, so you would not proceed if you wanted to solve it by using the sine law. But how many of you maybe would be more comfortable just finding that next angle using the cosine law again? The cosine law is really nice because it's not going to let you down. There's no ambiguity about it. So that's it. So you have some questions to practice, page 119. I wanted to give you a little bit of time here because I was worried about what we had left. I hope that wasn't too rushed at the end. That was okay? All right, so get to work on those questions, please. And I'll come around and I'll help you out.